Guys, today we will learn about Ohm's law and its applications. Humans' exploration on natural sciences never stops. In the 19th century, many physicists ran many experiments to investigate the relationship between voltage, current, and resistance in electrical circuits. In 1826, the German physicist Ohm concluded through experiments that the current in a conductor is proportional to the low voltage at the ends of the conductor, and inversely proportional to the resistance of the conductor. This is the Ohm's law. Since it does not contain a power supply, it is called Ohm's law for partial circuits. If it's expressed by the formula, I is equal to U over R. This is our basic formula for electricity, where I is the current through the conductor in amperes. U is the voltage across the conductor in volts. R is the resistance of the conductor in ohms. Let's understand the physical meaning of Ohm's law. For a given resistance of a conductor, the voltage applied across the conductor increases by a factor of several, and the current increases by a factor of several. At a certain voltage, the resistance of a conductor increases by a few times, and its current decreases to a fraction of its original value. So can we just say that the resistance is proportional to the voltage, and inversely proportional to the current? Of course not, because resistance is intrinsically determined. It is mainly related to its length, material, cross-sectional area, and temperature. So, when we calculate it, we should consider whether the voltage is in the same direction as the reference direction of the current. When the voltage is in the same direction as the current references, I is equal to U over R. When the voltage is in the opposite direction of the current, a negative sign should be added. Let's look at an example of a specific application. When a car bulb glows, the voltage across its terminals is measured to be 12 voltage, and the current is 0.33 amperes. Find the value of the resistance of the bulb when it glows. According to Ohm's law, I is equal to U over R. We deform the formula, that is, R is equal to U over I, and substitute the values into the formula. Then we can calculate the resistance of the bulb when it glows. Let's look at another example. As shown in the figure, it is a device to automatically determine how much oil is in the tank. R is a sliding rheostat, and its metal slide is the end of the lever. From the scale pointed by the needle of the fuel gauge, we can tell how much fuel is in the tank. As the volume of oil increases, the float moves up. The sliding contacts of the varistor move down. The effective length of the varistor becomes smaller. The varistor R decreases, and the total resistance in the circuit also decreases. According to Ohm's law, it becomes larger, and the deflection of the fuel gauge needle increases. This is the schematic diagram of an alcohol tester. Since the resistor of the alcohol gas sensor decreases as the concentration of alcohol gas increases, if the concentration of alcohol gas tested is greater, the resistance of the sensor decreases, and the total resistance of the fixed value resistor in series with the sensor decreases. According to Ohm's law, the higher the current in the circuit, the voltmeter measures the voltage across the fixed value resistor. The greater the voltage across the constant value resistor, the greater the voltage indication. In addition to partial circuit Ohm's law, there is also whole circuit Ohm's law. A whole circuit is a closed circuit that still has a power source. Let's first introduce a few terms. External circuit, the circuit outside the power supply. including appliances, wires, switches, and so on. Internal circuits, that is, circuits inside the power supply. External resistance, total resistance of the external circuit, denoted by R. Internal resistance is the resistance of the internal circuit, usually the internal resistance of the power supply. It is referred to as internal resistance and is denoted by R. The external voltage is the voltage across the terminals of an external circuit, often referred to as the terminal voltage, and denoted by U outer. The internal voltage is the voltage across the terminals of the internal circuit and is represented by U inner. Let's focus on the external and internal voltages. When there is current passing through the circuit, there is a positive to negative flow of current in the external circuit. At this point, there is voltage across the outer resistor and also across the inner resistor. The voltage consumed on the external circuit is called the external voltage, and the voltage consumed on the internal circuit is called the internal voltage. The electromotive force of a power supply is equal to the sum of the external and internal voltages. Ohm's law for closed circuits is that the current in a closed circuit is directly proportional to the electromotive force of the power supply, and inversely proportional to the sum of the resistances of the internal and external circuits. Let's use whole circuit Ohm's law to investigate the relationship between the terminal voltage and the load. The terminal voltage is the external voltage. According to Ohm's law of a whole circuit, when the external resistance R becomes large, the current becomes small, and the terminal voltage becomes large. Similarly, as the external resistance R becomes small, the current I becomes large, and the terminal voltage becomes small. Now let's look at the danger of short circuit. Through Ohm's law of whole circuit, in a short circuit, the external resistance R is equal to 0. And I short circuit equals E divided by R. I short circuit equals E divided by R. Due to the small internal resistance, the short circuit current is very high and could burn out the equipment. Let's look at a case of a car. When starting the vehicle at night, at the moment the engine starts, we can notice that the interior light dims for a moment and it brightens up again. This is why, when the car is started, the battery has to spin the starter. At the moment, the solenoid switch is on. Since the starter armature is not rotating, no counter-electromotive force is established. That is, the starter is short-circuited. The total resistance when starting the main circuit is just over the millions, and the starting current is very high, reaching up to 1000 A instantaneously in extreme cases. According to the Ohm's law of full circuits, when starting the vehicle, the voltage consumed by the resistor in the battery is higher and the terminal voltage drops drastically. That is why the interior lights of the vehicle dim. The charging process of a new energy electric vehicle plugged into a charging gun can be simplified into 3 stages. In the first stage, when no charging gun is plugged in, switch S3 is normally closed. In the second stage, press the charging gun button, and switch S3 is disconnected when the gun is inserted. In the third stage, when the charging gun is inserted into the slow charging port, S3 returns to normally closed. Try to analyze in these 3 stages how the ground voltage of the charging CC changes. In stage 1, with no charging gun plugged in, it's in open circuit, and the ground voltage at CC is plus B. In the second stage, when the circuit is on, since switch S3 is disconnected, there is a resistance R in series in the circuit, R3 and RC. Since R has a voltage drop, the ground voltage at CC is less than plus B. In the third stage, the circuit is still on, but switch S3 is closed. The effective resistances in series in the circuit are R, and RC and the total resistance become smaller. According to Ohm's law of full circuits, the total current becomes larger, and the voltage consumed by the internal resistance R increases. Compared to the second stage, the CC voltage to ground decreases further. Now let's go back over what we talked about today. We dealt with partial circuit Ohm's law and whole circuit Ohm's law. Ohm's law is used in automotive circuits in many ways. We need to learn how to use it and be good at summarizing and discovering, like the scientist Ohm. That's all for today. Have you learned it all?